quick video on the double slit experiment because people are having trouble finding that formula. So if you're just here for the formula, I'll put it up here for you so you kind of know what we're going for. However, I'm going to go through the derivation of the formula if you're interested in that. So stay tuned. But this is what you need for the test. So if that's all you came for, run off and be happy with it. It will solve the problems for you. But let's see where that formula came from. So these are our slits right here. And let's say they're separated by some distance s. S right here. And the slits are on a platform that is distance d away from, let's say, d right here, away from the screen. All right? And the center where the light hit, the very center where the light is most constructively interfering, its brightest, this fringe, they call it like the center fringe. They label it M0, so we'll label it M0. This is M1, this is M1 as well. The distance between M0 and M1 we'll call W for width. W. And M is just an indexing number. It just allows you to keep track of this. It's all integers. So you're not using like 0.5 of one, like 0.5 and pi and any of those delightful numbers that aren't 1, 2, 3, 4, etc. So they just allow you to keep track of which fringe you're at. And we need to involve the wavelength somehow. So we will call the wavelength lambda, like is standard convention, and just leave this up here to remind ourselves that wavelength is equal to lambda. So now we have this equation set up, and you can see where everything is in it when it finishes. But where does it come from? This is when you have to start doing some funky geometry that doesn't quite make sense because of all of the assumptions you have to make, but bear with me. It should clarify this formula when we get done. So the light from each of these places has to travel a different distance to reach the point up here, this M1. And the difference in distance has to be a multiple of the wavelength. It has to be a multiple of lambda, because otherwise the waves will not constructively interfere. They'll not line up with both of the crests at the same place, and they won't be as bright as they would be at a place where they constructively interfere. So we know that this length here is a m lambda, okay? And m, coincidentally, is this m as well. So this m lambda, how do we go about getting it? Well, we have to make an assumption. And this is what I was talking about. Things might get a little confusing if you haven't done anything like this before. So we have to assume that these slits, the distance, are very close together compared to this distance, which means S is much, much smaller than D. And that allows us to do a couple of interesting things. First of all, it allows us to really easily solve for the m lambda. So in this little right triangle, this would be m lambda. Because the lines are parallel, this is the difference. If you get this nice little rectangle going right here, this is the difference in the distance they'll have to travel to reach that point. And we also end up getting nicely this right here being S. This is the distance between the two slits. So a way that we can relate these things in math is with trigonometry. So setting this angle theta right here, which is also this angle and this angle. Setting this angle theta right here, we can talk about S and m lambda in a formula. So we can do sine of theta, because sine of theta is opposite, which is m lambda, over hypotenuse, which is S. Sine of theta is equal to m lambda over S. All right, but how does that help us do anything over here? This is what we want to know about. We have to make another assumption. And this one might be a little bit harder to think about, but you just have to keep in mind that these angles are incredibly small. This distance is so much bigger than S that the sine of theta is extremely close to the tangent of theta. So close that we can kind of treat them the same way in our equations. And this allows us to do something super useful, because this triangle right here with this width, with this W and D as lengths, shares this angle theta with this angle theta. And that allows us to take the tangent, which would relate W and D, and set them equal to M and lambda, because this is also equal to tangent of theta now because we've made this assumption. So what does this look like? Tangent of theta, again, theta is this angle here, and this angle here, and this angle right here. And this is the one that we're talking about because we're talking about this triangle, the one that I am drawing over right now, rather sloppily. So tangent of theta is equal to m lambda over s. Now, tangent of theta is opposite over adjacent, so w, which is opposite, over d, which is adjacent, is equal to m lambda over s. And you can just rearrange that nicely into our golden formula here, w equals m lambda d over s. And that's how you get the formula for the double slit experiment. There's a different formula for single slit experiment. Don't use this one for single slit, only use it for double slit. I hope this was useful, and good luck on that test, everyone.